All right, moving on to Unit 4A, Day 1b, which is just the second part of Day 1. Going to continue on with the circle and the angle and degrees and revolutions and radian, all that talk. So I can find the arc length of a given circle, just the length of the arc. You know, if you're given an interior angle, could you find the arc that intercepts? And I can convert between angular and linear motion. So if I say a wheel rotates 30 degrees and the wheel has a diameter of 20 inches, how far did the wheel move? So that's linear motion. It's how far did it actually move, how far did it actually roll. So given a radius of 4 inches, find the circumference. Okay, so if you know the radius, circumference is always going to be 2 pi times the radius. So if I plug 4 in there, so it would equal, circumference is going to equal 2 pi times 4. Circumference equals 8 pi. You can leave it that if you want to. I might just leave that as it is. So you can put in your calculator too and find the exact answer, 8 times pi, but this is exact. Find the length of the arc in inches with a 90-degree intercepted arc. So same circle. We're sticking with the same circle here. So say here's the circle. They had a radius of 4 inches, and this guy's got a 90-degree angle. How long is that guy? That's what we're trying to find. How long is that? Well, that 90 degrees, probably the easiest way to do this thing, 90 degrees is 90 degrees out of 360, so that's really just 1/4 of the entire circumference. The entire circumference was 8 pi. So multiply this out, do all your reducing, and it ends up being 2 pi. So 2 times 3.14 is about 6.28 would be the length of that guy. So 6.28 would be that arc length. Now find the length of the arc in inches of a pi over 3 radian. So instead of giving you a degree measure, we're giving you a pi over 3 radian. So this, I don't know what's going to be easiest here, but you could do pi over 3 radian. You could convert that to degrees if you want to. So if I want to convert that to degrees, remember pi radian is the same thing as 180 degrees. Pi radian. So this is going to end up being, 180 divided by 3 is 60, so 60 degrees. So that's the same thing as 60 degrees. So now 60 degrees out of 360 degrees times the entire circumference, 8 pi. If you do all your reducing, that's going to end up being 4 over 3 pi. We should say inches on this, pi inches. Okay. So now, what kind of formula are we using here? So let's do some variables here. Let's say that S, capital S, is going to be arc length. Okay, it's kind of two ways to do this. It depends if you are given a radian measure or if you're given a degree measure. It's kind of two ways of doing it. Okay, so for the arc length, you're going to take, to find S, to find the arc length, if I give you the radians, you're going to take the radians divided by 2 pi, okay, and then multiply by, because when you divide by 2 pi, that's out of the entire circle. Okay, so I could have done that up here. It's just pi over 3 divided by 2 pi got kind of weird. I can go back and do it, you get the same answer. But so how many radians you had divided by the entire circle, so that gives you a fraction of the circle. Much the same way over here, we do the degrees divided by 360. We're just trying to find what fraction of the circle are we looking at here. Take that times the entire circle. So 2 pi r. Same thing over here. Take it times 2 pi r. And do some reducing. So 2 pi pi. This one works out really nice. It's going to be the radians. The degree measure in radians. So we can say radians times r, where r is the radius. Okay, well, another thing we should say here is when I take the radian measure, if I want to call it, we'll call it theta, because that just seems that's the typical variable for measuring an angle. So if theta is in radians, I'll just put this. So theta, whatever theta is, if it's 2 radians, we'll take it 2 times whatever the radius is. The radius is 5, so 2 times 5 would be 10. Okay. So then over here, not a whole lot cancels. I got 2 and 3/6 to be 1 and 180. Again, we'll say that degrees is the theta measure. So we'll say theta over 180, and then pi r, where r is the radius. Sorry, the radius. Okay? So whatever the measure is, divided by 180, multiplied by pi and whatever the radius is, which is kind of what we did up here. We multiplied by 2 pi, but we divided by 360. Here we're dividing by 180, and we multiplied by pi because the 2 and the 360 reduce to 1 and 180. Yeah. So if it's given in radians, it's a lot easier. It's much easier. It's just whatever the radians are times whatever radius is, multiply them out, you get your arc length. This one's a little more difficult, but some of you might find it better just to do it an intuitive way, and that's fine. Whichever. Here's some formulas that might help, but don't necessarily have to do it. Let's see. A 40-inch pendulum swings through an angle of 18 degrees. So just think, you got this pendulum that's hanging down. It's 40 inches, and it's swinging back and back and forth 18 degrees. Now, obviously, it's going to be slowing down, but at this moment, it's swinging back and forth 18 degrees. Maybe it's like a metronome kind of thing that doesn't stop. Find the length of this arc. So we're trying to find this arc right here in inches through which the tip of the pendulum swings. Well, they gave it to me in degrees. Theta is in degrees, so I can use this guy over here. So I'll say this is going to equal, if I put theta in there, I'll be 18 degrees pi r over 180 degrees. Let's see here. So 18, well, if I do some reducing, and I realize I'm off the screen here. For the radius, I need to plug that in too. I need to plug in 40. I didn't plug in the radius, so I was getting stuck there for a second. So do all the multiplying. So the degrees actually cancel, so the degrees are no longer in the answer. This is 40 inches, so the only label left is inches. I got 18 times 40 times pi divided by 180. If you put it on the calculator, you do some reducing, you actually get 4 pi inches or 12.57 inches. This is more exact. This is a very close estimate if you need to know an actual number. The windshield wiper of a bus is 24 inches long. I always think the windshield wipers on a bus like hang down and go back and forth like this too. So that's how I'm going to think of it. So windshield wiper of a bus is 24 inches long, and it's going back and forth, cleaning this window off for the driver, and the tip wiper of the wiper traces out 18.85 inches. Now, how much of a revolution is that? First off, let's just figure out what theta would be on this one. So what is theta? And I can convert theta into revolutions. So first off, I'm going to use this formula. So the arc length is going to equal theta times what a radius is. Well, the arc length is 18.85. I don't know what theta is yet, but I know the radius is 24. So divide that over. So theta is going to be, let's see, so this would be 18/85 over 24. If you divide that, so theta is 0.785 radians. Okay, 0.785 radians, and that's just a radian measure. I'm sorry, I'm off the screen again. So it'd be 0.785 radians. Now I need to convert that, so 0.785 radians over 1. I want to convert that. I want to know revolutions in my answer, so I need revolutions on bottom and radians on top. Whoops, I need radians on bottom and revolutions on top. I said that backwards. So radians and revolutions, well, if you want to do, I'm really messed up what I wrote. So 1 revolution, is 2 pi radians. So I'm going to divide by 2 pi. Put in the calculator, it actually ends up being 125 revolutions, which ends up being 1/8 of a revolution. So either way, 1.125 revolutions or 1/8 of a revolution. It's not very much. That windshield wiper is not wiping very much as it hangs down there. Hopefully that driver can still see out the window. A car wheel is 14 inches, has a 14-inch radius, kind of a small car wheel there. Through what angle does the wheel travel if the car is moved 2 feet? So think, I got this wheel, the radius is 14. It has rolled, so it's rolled 2 feet. So I think 2 feet would be 24 inches. Well, to get there, I had to wrap around 24 inches. So really, I'm doing my arc length. So this arc length is actually 24. I'll just put this from here to there is 24. Also, I have to roll down to make 24. So it's always easier to use radians. It's so much easier. It doesn't tell you what your answer has to be. It says through what angle. So it doesn't say degrees or radians. So I can do both. I can do either. If Math Excel gives you a specific one, you have to go that route. But so the arc length is actually 24. The angle I'm trying to find, and the radius is 14. So I divide this over. It's 12/7 radians. That can be one answer. If you want to convert that 12/7 radians, I want to convert that to degrees. So radian, degree. So remember, pi radian is 180 degrees. It's probably the easiest way to do it. Radians cancel. And you do have a pi here. There's no pi in this answer. There's no. This is 12/7. It's not 12/7 pi. So the pi doesn't reduce here. So 12 times 180 divided by 7 over pi, or 7 times pi, 98.2 degrees. Don't need degrees there anymore. Okay, let's go to the back. So the back, it gets kind of interesting for me, I think. It's just crazy to think, because I do have a long drive. I don't know if I explained that to you guys, but I drive about 50 minutes each day, and I drive a car that has kind of small tires, a hybrid that has small tires. This kind of makes me think, like, how many times is my tire spinning per minute, per second while I'm driving down the road? Of course, abiding by the speed limit the whole time. Just blows my mind how fast it is. Okay, so converting angular momentum to linear motion. It's kind of what we just did in the last one, where we talked about how it rolled, and if it's rolling, and how much of the circumference, how much of the arc length are we covering. So Juan's truck has wheels 26 inch in diameter. Keep in mind that's a diameter, and we're talking about radians and radiuses, so we need to change that eventually. If the wheels are rotating 630 revolutions per minute, RPMs, find the truck's speed in miles per hour. And all this is going to be a crazy unit multiplier problem. Okay, so first off, I know the wheels are rotating 630 revolutions per 1 minute. Okay, and then I'm going to multiply this out. So I eventually get to miles per hour. So minutes need to become hours eventually. So 60 minutes in 1 hour. Minutes cancel. So now I've got, if I multiply by 60, it's revolutions per hour, but I don't want that. I want miles per hour. So I got to do a translation here. A revolution is how far. Well, it's not going to be, I'm not going to be able to write it down in miles, but I can write it down in inches. So I know that if the circumference equals 2 pi r, and well, if a radius is half of this, 2 times the radius, that is diameter. So the circumference equals pi times diameter. If I take out 2r and just put diameter in. So the circumference, so 1 revolution is going to be pi times the diameter, so 36 pi. Okay, so that's going to be inches, by the way. So 36 pi inches. And so revolutions, so now I'm in inches per hour. Well, now I got to change that inches into feet. So 12 inches in 1 foot. Cancel out the inches. Now I'm in feet per hour, but I want miles per hour. So I got to multiply feet an hour, so 5,280 and a 1, so the feet cancel. And look at my units. The only units left are going to be hours. I'm sorry, miles, not hours. Miles, 1 mile. And then the bottom unit is hours. That means I got it right. So my answer is going to equal so many miles per hour. Okay, which eventually I'm going to divide all this out. But I would just put all this in the calculator. So 630 times 60 times 36 pi, get an answer, and divide that by whatever 12 divided by 5,280 is. So instead of writing this as a ratio, I'm just going to have 67.47 miles per hour. So let's go like this, miles per hour. Let me put in the calculator. That's a pretty good speed. It's going 630 revolutions per minute. It's going 67.47 miles per hour. What if an automobile tire has a diameter of 17 inches? The wheels will be rotating at how many RPM, so revolutions per minute, if the vehicle is going 60 miles per hour? So say you're legally going down the road, traveling 60 miles per hour. How fast is your tire rotating? So we're going to do revolutions per minute, and I'm also going to ask you for revolutions per second. So I got two answers here. So first off, I'm going 60 miles per 1 hour. And I like to take care of time first. Let's convert hours to minutes first. So 1 hour is 60 minutes. So I got miles per minute, but I want revolutions per minute. This guy here, again, if the diameter is 70, circumference is 2 pi r. Well, 2 and r is diameter, so I could always put pi times diameter or pi times 17. So it's going to be 17 pi inches. I'm sorry, hold on a second, let me wipe that. I'm way too early on that one, okay? So miles, I'll go 1 mile is 5,280 feet, and then 1 foot is 12 inches. So right now, let's see, miles are canceled, feet are canceled. Right now I'm measuring how many inches per minute, but I don't want linear, I want to convert that back to revolutions. Okay, so in my conversion here for this tire is 1 revolution is the same thing as up here, 17 pi inches. Okay, so now the inches cancel out, and I've got revolutions per minute. That's what I want for my first answer, is revolutions per minute. So multiply all this together, you get 1,186.36 revolutions per minute. That is insane that a tire's revolving that fast. Now, how many per second? We'll just divide by 60, so it'd be 19.77 revolutions per second. So that tire is revolving. If you have that small of a tire, if you have a 17-inch tire, your car is revolving. The tire is revolving almost 20 times a second. So you can understand why you want to have good tires on the highway. Okay, so nautical miles versus statute miles. What we know statute miles. That's what you've known your whole life. That's what we're talking about up here is miles, or that miles is statute miles. But we're going to look at nautical miles. So here's a conversion. Just basically all it is the length of 1 minute of an arc along the Earth's equator. So basically a minute is 1/60th of the degree. So 1/60th of the degree would be how many miles to the equator? That's 1 nautical mile. So they're very close to a statute mile, but it's not quite the same. Basically all it is here is we're using this conversion. We want to use, so find the distance in nautical miles given a distance of 1,000 statute miles from Florida to Washington, D.C. So if it's 1,000 stat miles, and I want to convert to nautical miles, well, I need statute miles on bottom, I need nautical miles on top. The conversion for that, you can either use either one or the other, just stick with this one. So 1 statute mile is 0.87 nautical miles. Multiply those together, and you get 870 nautical miles. Okay, so down here, kind of same idea. We give you nautical miles, convert it back to statute miles. So Find the distance in statute miles, so 2,487.5 nautical miles. And the conversion here, it's always easier to have a 1 on bottom, so I'm going to use 1.15. Nautical miles cancel out, multiply it out, you get 2860.625 statute miles. So there's way more to that. I'm not sure how much more we need to go into it though. Like, just it has to do with you know, a lot of times I think planes and boats use nautical miles because it's more accurate. Since you actually travel on a curvature of the Earth for a long distance, it actually is more accurate. But for the most part, we're, you know, as mathematicians, we used to be able to calculate the number itself.